This example deals with bearings and headings, so a lot of the time the trickiest part is getting the picture down. So a good idea is to start with plenty of room for yourself, have an idea of where that picture is going to go, but in the end, leave yourself space in case you need to adjust as you go. So in this case, a hiker walks 4 kilometers from point A at a heading of 30 degrees to point B. So I know 30 degrees off of north is something like that, so I'm going to label it right here. This is where he starts at point A, and he walks at 30 degrees. I know that 30 degrees is there because it's 30 degrees off of true north. So north is going straight, that 30 degrees goes up that way. And I'll call that point B here. Point B, that distance is 4 kilometers. All right, next part I know is that the hiker then walks 6 kilometers at a heading of 285 degrees to point C. So he walked from A to B, and now at B he's going to turn and go to C. So the bearing of 285 degrees, wherever you see a bearing or a heading, you're going to draw in this. Off of true north, right, I go clockwise. So whereas 30 degrees was just right here, nice and easy, 285 degrees is going to go around, that's 90. Then there's another 90 to 180. Going due west is going to be 270. So I'm going to go 285, which is 15 degrees more than straight west. I made that line longer because I know he's going 6 kilometers that distance. So it should be a little bit longer than 4 kilometers. It's approximate, it's a sketch. I'm going to draw it to there. Okay. Now, let's see what I have. This is point C. And my first question says, how far from point A is the hiker? Since he went from A to B, then to C, the distance I really want is this. Okay. My picture looks like it's got a lot going on right now. So I also want to draw a simpler version of the picture. Just a triangle. This is A, B, and C. The things that I know, this is 4 kilometers, this is 6 kilometers. The angles right now, I don't know any of the full angles in the triangle, but I can figure them out. So because this is 30 degrees right here, it is alternate interior with the angle down here. Okay, so that relationship is going to hold whenever you see bearings and headings, alternate interior angles. So that's 30 and that's 30. But the angle I really want is inside the triangle. And I know the 30 and my missing angle are complements of each other, which means they add to 90. So that has to be 60. Putting it all together now, this whole angle made up of these two pieces would be 75 degrees. Okay, my simplified picture shows it a lot clearer. There's a lot going on here, so the simplified picture helps. First thing I want to find is the distance from C to A, which is this. In other words, that. And it's an oblique triangle. I'm using my process of elimination. I'm going to use law of cosines because it's side, angle, side. Let's use my board over here to solve it. So I want to set up x squared equals 6 squared plus 4 squared. Got it all in there. Here, because I'm solving for a side length, I can type that entire thing into my calculator, and I will get x squared equals 39.577. Use that exact number that's in your calculator. Take the square root of both sides. X is 6.291 kilometers. First answer, that's how far he is. Second answer asks for the heading or bearing to return from C back to A. So what I want to know is, how would he return back to his starting point? So what I really want to find in this case is the angle at C. Okay, let me make that better. There we go. So call it theta or call it C, whatever you want to call it. Now that I have this side length of 6.291, I can use the law of sines. It's going to be sine of 75 degrees over 6.291, because that's a matching pair, equals sine of C, or theta, whatever, over the side it corresponds with, which is 4. Cross multiply, take sine inverse, you get the measure of angle C to be 37.891. So that's the trig behind it, but that is not our answer. The question asks, what is the heading to return from C back to A? So if I kind of focus in on my picture a little bit more, clear a little room, I want to know the bearing to return from C to A, so I'm going to draw in that. Now, the 37.891 is the angle in the triangle, so that I'm going to call 37.891 right there. That's not a bearing, that's not a heading, right? So the 15 degrees, I can figure out this additional little piece here because it's alternate interior with 15 degrees. At that point, looking at how I found my heading of this whole problem, my heading is found off of north, going clockwise. So the total degrees from here down to there is going to be 90 degrees for this first chunk, plus 15 degrees for this second chunk that again is alternate interior with 15, plus 37.891 degrees. Those three things together tell me the rotation from clockwise to get there, which is 142.891 degrees. You can give that as just a degree like that, or if you prefer using the cardinal directions, northeast, southwest, you want to base it off of the north-south line. So an additional possible way that you could give this answer is looking at what is this piece here. That piece is 180 minus 142.891, which is 37.109. So you would be going south 37.109 degrees east. Okay, you could come to these two answers a couple different ways, but either of these are acceptable for telling your heading to return.